Hello guys, so today we are going to discuss about this question. So we are going to solve this by integration by part technique, and then we are going to show that in, which is this integral, is equal to that. Okay, so what we are going to do, firstly we will consider the left hand side. So in, which is going to be cos nx, right? So I'm going to distribute this in this way. Integral cos nx means cos x, then cos n minus 1 x dx. So what is the reason I choose this? The reason is this. I can see cos n minus 1 x. So that is the clue to split this one into this. Otherwise there is no clue, right? Because this term we should know, this term is nothing but uv, right? So this term is uv. So one of the terms should be this. So we are going to choose this to be u. Then exactly this will be copied here. So that's the clue. So that vision is what we should have when we try to construct. Okay. So this is u. This is going to be v prime now. So u prime from here is going to be, so you have to be careful when you differentiate. So n minus 1, cosine n minus 2, x, and then cosine we are going to differentiate, and that would be minus sine x. So you have to be very careful. So from here we can find v is going to be sine x. Cool. So now we are going to apply everything in here. So in is equal to uv is what we are going to form here. So u is going to be this and v is going to be that. So we are going to peacefully copy the stuff here. So that would be cosine n minus 1x minus, now we have to be very careful, integral. So here you should have v is going to be sine x. Okay, I'm going to put that here. And then u prime, so u prime has a minus and this guy. So minus with this minus is going to be positive. Then n minus 1 I'm going to put here. Then there is another sign, so it's going to be sine squared. And this cos n minus 2 is going to be copied here. Cos n minus 2 x dx. Cool. Neat. Now what we do, for the further simplification, this one I'm going to write in terms of 1 minus cos squared x. So when I do that, right? So when I do that, okay, let me copy this, plus n minus 1, right? Big bracket. So 1 times this is going to be cosine n minus 2 x, right? Then I have minus, when you multiply these two, it's going to be cosine nx, right? Then what I'm going to do, I'm going to have my integral here, and then I'm going to close the bracket. Cool. So integral I'm going to put accordingly. Okay. So left hand side you have in, and then this term is copied, right? So next bit would be integral. Okay, I'm going to distribute this one now. I'll show it to you. N minus 1 integral. Here you get cosine n minus 2x dx. So I distribute the operator minus this n minus 1, and then I have integral cosine x dx. Cool. So let me write this term. So what we have here is cosine n minus 1x. Okay. And now you can see with the definition. So what was our definition? Our definition was in cos n. So when you have n minus 1, n minus 1 should be there. Okay, so that's the pattern we recognize. So here you can see in minus 2. Here you can see in. Cool. Now we peacefully put things together. So it's going to be sine x and then cos n minus 1x plus n minus 1 n minus 2 here minus, then we get n minus 1 here, and then in over here. So now, okay, so left hand side I have in. Now I'm going to bring this guy to this side. So when I do that, I get in plus n minus 1 in, and in the right hand side I just have sine x, then I have cos n minus 1x, then plus n minus 1 n minus 2. Cool. So I'm just putting the things together. Now you can see, so 1 to 1, 2 minus 1 is gone, so this is going to be nin, right? So I'm going to divide the whole right hand side by n, so it's going to be in now is equal to 1 divided by n sine x cosine n minus 1 x plus n minus 1 divided by n n minus 2. Cool. This is what we want to do. Prove. Okay. Now, next one would be, so we wanted to, the b part we had I5, so that would be integral cosine 5x dx. So how you do this? So, okay, so n is equal to 5 now, right? So we will apply n is equal to 5 here. So I5 is equal to 1 divided by 5 sine x. So this is going to be cos to the power 4x. Yeah, so this is going to be, if you put 5 here, so 5 minus 1, 4. So 4 divided by 5. This is going to be 5 divided by 5 minus 2 is going to be 3. Okay, so this is my first equation. Cool. So need to evaluate this. So I3 we can write similarly. So I3 is going to be, again we are going to use this 1 divided by 3, then sine x, then it's going to be cosine. When you put 3 over here, it's going to be squared x. So when you put 3 over here, 3 minus 1, 2, 2 divided by 3, and that's going to be I3 minus 2 is going to be 1. This is my second equation. Let's think about what is I1. Okay, so I1 is integral cosine 1 x dx. Okay, so integral cosine x dx is nothing but sine x. Cool. So that is straightforward. So now what we can do, right? So what we can do, we can simply substitute this whole thing. So we can simply substitute this whole thing into here. Okay. So I1 is sine x, so we get the answer. Okay, let's see. So if you do that, we'll do it here. I5 is going to be 1 divided by 5 sine x cos 4 to the power x plus 4 divided by 5, and I'm going to put this one, so big bracket, 1 divided by 3 sine x, then cos squared x plus 2 divided by 3, I1 is going to be sine x. Sine x. Cool. That's answer. Okay. So that's how you properly use integration by part, and this is how we did this question. Thank you.